In this video, we will solve the equation 9 plus the square root of k equals 3 and formally check our solution. In this video, we will introduce the concept of an extraneous solution. But let's first solve this equation before we get into that concept. So the first step in solving an equation that has radicals is to isolate one radical. In this equation, 9 plus the square root of k equals 3, there's only one radical, and so to isolate it, we're going to subtract 9 from both sides of the equation. When we subtract 9 from both sides of the equation, we will end up with the square root of k equals -6. Now the standard equation solving process for radicals is to use an exponent that matches the index of the radical. In this case, since we have a square root, we'll end up squaring both sides of the equation. So we'll end up with the square root of k quantity squared equals the quantity -6 squared. On the left half of the equation, the square root of k squared, the square root and the square cancel, leaving us just with k. On the right side of the equation, -6 squared, -6 times -6, is a positive 36. So we have solved the equation and come up with a potential solution of 36. We now need to go back and formally check the solution in the original equation. To check, we'll substitute 36 back in for the k in the original equation, and we'll be checking, is 9 plus the square root of 36 equal to 3? Well, following order of operations on the left side of the equation, the square root of 36 is 6, and so we end up with the question, is 9 plus 6 equal to 3? Well, hopefully we recognize 9 plus 6 is 15, and 15 does not equal 3. The only potential solution to this equation was 36, but when we check it, it does not check out. This tells us two things. One, that there is no solution to this equation. There is no real number that I could substitute for k to make this original blue equation, 9 plus the square root of k equals 3, a true statement. When we end up with solutions that appear to be solutions from the work that we've done, which all the work we did was exactly what we should have done, but they don't check out in the original equation, these are called extraneous solutions. If you go to the line above k equals 36 and look how we obtained k equals 36, you'll notice the equation we actually were working with was the square root of k equals -6. If we had actually stopped there and contemplated what we were looking at, if I take any real number and substitute it in for k, if the number is positive, the square root of that positive number will be a positive value. If I substitute 0 in for k, the square root of 0 will be 0. And if I substitute a negative number for k, the square root of a negative number is not a real answer. It won't ever equal -6. There is no real number that I can substitute for k and take the square root of that value and obtain a negative value. There is no way to make this square root of k equal to -6 a true statement. So we could have actually stopped right there if we had recognized it. The fact is, many of these equations will have extraneous solutions. Typically, they won't be as obvious as this. Typically, the issue where we're going to have that extraneous solution will be somehow embedded and hidden within the work that you're solving. This is why it is critical that you always check your solutions when you're solving radical equations. By squaring both sides of the equation or raising both sides of the equation to other powers, you introduce the potential that what could not have been true seems to be made true. The square root of k can't equal -6, but k equal to 36 seems like a reasonable answer.